Okay, so we are basically here to tell you a bit about the behind the scenes of Deploio. It gets a bit more technical, I'd say. But yeah, it's me. My name is Sebastian Nickel, but everybody calls me Nick, and that's Cyrill.
Cyrill.
Everybody calls you Cyrill.
Yes.
Yeah. So, state of the development. What is Deploio already? As Tom already introduced and told you, Deploio creates runnable applications from source code by leveraging cloud-native build packs. So maybe you already know, for example, those Docker files where you have single instructions in them. That's not it, right? It's basically build packs, and they are trying to analyze your code. They try to find out the language, what is written in, and then they actually try to get it containerized, and then we run it, basically. What it does, need to try to figure out all also like settings and maybe also environment variables, what your framework or your language needs. And at the end, the container image will be created, and we will deploy that in a Kubernetes cluster. And the Kubernetes cluster is our own distribution, if you want to call it like that. I don't know. It's called NKE, very design, right? 9 Kubernetes engine. And yeah, we run that with the help of, what is it, Rancher and Cilium, and I don't know what else.
Yeah, lots of
some stuff, basically. And NCTL is the CLI, which basically talks to our API to create deploy applications. And Cockpit 9CH is the UI part, right? Which can also be used to create the deploy applications because it's talking to the same API in the end. I think that's still me, right?
Yeah.
So, and yeah, what are features of Deploio? What it basically does is it detects Git changes. So you have your code somewhere in the repo. It might be public, might be private, and Deploio basically connects or checks for news in that in a specific interval, and then it grabs the code and builds something new. We have automated TLS certificates based on Let's Encrypt and Cert Manager. That's how we do it in NKE. We have built-in runtime logs. So yeah, I guess it says it all, right? You can see the logs of when we build the application, when we containerize it. And also, during runtime, the container image, which gets built, can be downloaded via NCTL, for example. If the app, for example, is not working, it's actually worth to download the image and then check, for example, the entry point of the image, if you're familiar with Docker at all, or with Docker files or Docker images, to get actually around some issues. We have support for Ruby, PHP, Node.js, Go, and recently Python. Easy basic authentication support. You can basically just set a switch that will come up with a random generated password, and then your app will be basic auth protected. And that's also something which our previous PO really wanted, is some configuration can be given by a .deployo YAML file in your source code, basically. So you can also just have a part of it, like part of the configuration, actually everything which is runtime related, not build time related, can be in that Deploio YAML file in the source code of the application. If you change it, you do a git push, and then Deploio will detect it and adapt it.
Yeah, that's about it.
That's about it.
So next, we'll have a quick live demo, just so you actually see it or see something. So as Nick already told you, we have this NCTL. That's our main CLI tool. It's now huge. But yeah, basically, if you do an NCTL -H, you'll get the help as expected. And yeah, interact with 9 API resources. The thing about this tool is it can interact with any resources that 9 provides. So not just Deploio, but also other things like databases. Well, not yet, but soon also databases, which you might also need if you are a user of Deploio. And then if you get started, you will need to first log in and all that. That's about it. I just create an app now. Use that one. So essentially, it's pretty simple to create an app. It's just NCTL create app. Then you specify a name if you want to. The Git URL here, it's just our Deploio examples. And in this case, the source code doesn't live at the root of the repository. it lives at the subpath called go. So I have to supply this. But usually you just point it to your Git repository. In this case, it's publicly accessible, so there's no need to do any authentication. So I'll hit, oh, yeah, it already exists. Of course, I didn't clean it up. Let me just clean it up. All right, perfect. So yeah, that's basically the process. It tells you it has been created, and now the build starts. That triggers all kinds of things in our backend, and eventually you'll see the build logs appearing.
New version.
Yes, it's already in a new version that is actually not released yet, but I thought why not show it. So yeah, it will just show what it's doing. It's it's already running go build. So before it just cloned the Git repository, detected that it's go. And then it detects the go version. Here, the go build has been completed in 10 seconds. And then it assigns the launch process, pushes the image. It was too quick in this case, but yeah, there we go. And now I can click the link and it's up and running. That's basically already it for this simple demo. Maybe I can show something else. Update app. If I say env,
response text.
So I can, for example, customize this. So we have applications can have environment variables. So during runtime, these environment variables will be available to the application. So I can basically change this response text to hello TechTalk. Oh. Yeah, I didn't specify the name. So update it. And now I can maybe reload. Yeah, there it is. Hello TechTalk. So these kinds of environment changes or like runtime changes are pretty much instant, because the only thing we got to do is restart the app with the new environment variable. But of course, if you change something that concerns the build, so for example, if I push some new code, it will need to go through the build process again. So it takes a bit longer, depends on the app as well. I mean, if your app takes 30 minutes to compile on your local machine, it will take some time to compile on Deploio. It's not magic, but yeah, that's basically it. We do have a caching system in the build, so it doesn't need to rebuild or get everything again from scratch, but we'll have to see how that scales for big applications. I don't think we have any huge applications yet. A bit hard to tell. Well, our docs page is kind of huge, this NPM stuff, right?
It also takes a bit, yeah.
So yeah, that's always good to have these kinds of apps that you realize that that the cache is being used and stuff like that.
I think it's also one of the advantages of those build packs, right? Because in the end, you create a container image and it consists of multiple layers. And what they actually do is they cache the layer where a build application is in. So the whole Ubuntu base, which is down there, can actually be replaced. Whenever we do upgrades and we update the Ubuntu version, we don't have to rebuild your application. We just replace the layers and they get basically, how they call it, restacked on top. That's it.
Yeah, it's nice. So yeah, I guess we can go back to the presentation, or do we have anything else to show? I guess I can show that real quick. So we have these get, create, update, so these normal CRUD commands, and then we have a few special ones like logs. So for example, I can do get logs. I can do -f, so it will follow the logs. And let me just, I still have it here. So if I do this, you'll see new log lines appearing. So we can tail the logs like this. And you can also show logs of the build process with this command. So just logs build -h for the application, and then I'll get the whole build log. I can, for example, say I want more lines, and then I get all the lines. Yeah, that's about it. I think those are the most important commands.
There's a bit more like this. That deploy job command and stuff. But for
there's lots of smaller stuff. But yeah, that's about it. Yeah. I'll switch over to the presentation. Good. Yeah. At least we're done with that.
I think that's the
right here.
Yeah.
Good.
Is that you? Yeah. I don't know. Is it you?
No, that's still me.
We actually added the names who will speak, but we don't see them anymore. That's
why. So yeah, we already explained some of this stuff. So KPack is the tool that is making most of this possible, to be honest. It was founded or originally created by Cloud Foundry. Don't know if you know Cloud Foundry. But yeah, I think a few months ago, it was donated to the CNCF. So it's now a CNCF sandbox project. Is it sandbox? I don't know. But essentially, the good thing is it's in a community of open source companies, essentially, and it will basically guarantee that this thing will be maintained and will live on even if Cloud Foundry dies or anything like that, right? It's not attached to a single company, and that gave us lots of confidence, even though we already started, right? It was a bit of a gamble, but it's always like this with these open source projects. Of course, it's built on top of Kubernetes, which is also a huge open source project, and that's also CNCF stuff. So it's now basically under the same roof, essentially. We use Loki for the logs that you've seen before. So Loki is a product of Grafana, also an open source log storage solution. We're pretty happy with it, I think. The good thing is it requires very little infrastructure. It's quite simple to operate. You don't need like an Elasticsearch cluster and stuff like that. So yeah, it's fairly good. Docker distribution registry, that's just for the images. There we store everything. And yeah, for Loki and the registry, we actually had to do some stuff to make it multi-tenant aware. So the thing is, you can just spawn up a Loki instance and then put logs in it. But then if you want to get the logs out, you need to authenticate. And by default, at least, everything goes into the same sort of bucket or organization. Yeah, I guess it's a bucket even on S3. So that means everyone can see everyone else's logs, and that's not great. So there's a sort of multi-tenancy system in Loki, but it's very like you need to build it yourself a bit, put the pieces together. So we wrote a little authentication proxy that interacts with our authentication mechanisms. So even from the CLI, you can get a token from our API, and the token goes to Loki, and then you just get the logs that you're supposed to. So yeah, that we had to build. And for the Docker registry, it's basically the same thing, so that you can just download the images that you're owning. Yeah, and the whole thing is sort of orchestrated by our controllers. We'll talk a bit more about that, I think. Yeah.
So yeah. We basically have 3 clusters in use for the whole Deploio stuff and also other stuff at 9. We have our control clusters, and that's a Kubernetes cluster. And we only store API definitions there. Like they're also running pods, but only our reconcilers basically, and nothing else. So we use Kubernetes just as the API. Customers can create like definitions there, YAML files, for example, a Kubernetes cluster or a Loki or a registry or a Deploio app. And that like a reconciler is a piece of code which watches those YAML files. And if ever there's a change, it will do something, some logic. And it will apply, I don't know, it will either talk to an API or does something else. It's basically like an, I don't know how to say it, but it's like an automated Terraform or so, if you want to imagine it like that. But that's our API, and we solely using reconcilers. There's never like an HTTP service which takes an API request and does something. We don't do that. We always use Kubernetes for the API definitions. Then there's the other cluster, that's the Deploio cluster, and that's just divided into build nodes, or basically build node pools. We have one pool for building images and the other one for running the container images. Their KPack, as Cyrill just said, does the job, right? It watches your Git repo, builds it, throws it up to the registry, and from there we take over with reconcilers again, and then we do the deploying, the certificate, basic auth, and whatsoever. And there's the service cluster, which is our designated cluster for services. The name kind of implies that. For example, we run also customers locate their Docker distribution. What else do we have? Grafana Tempo, right? For example, for traces or whatever. Like all the services are basically running there outside of the customer's Kubernetes cluster. That's a learning we did when we started back then with GKE. We deployed everything on the GKE cluster, but then it was a bit hard because customers complained that we were taking their resources away. And that's why we said, okay, if it's possible, it's not always, if it's possible, we try to run the stuff outside of your cluster. Yeah, that's it. Any question? No? Good. Yeah, and for the backend, for just Deploio specific stuff, we actually have 3 API resources. Kind of self-explaining, I'd say. It's the application, right? That's what you created, Deploio. If you use NCTL or Cockpit, or I don't know, you could actually use Terraform. You can actually use Terraform to create Deploio applications. It contains the links to your source code, like links to your authentication material, like SSH keys or HTTP tokens. And it also contains the configuration, environment URL, environment variables, build time variables, and whatsoever. And we have a pretty, actually, also complicated configuration system, which we have on many layers. So you can set configuration on an organization level, on a project level, on an application level, and then you could also still have that in the mentioned .deployo YAML in your source code. And it will also be merged together in a specific order. And then like once the application basically is created, we will do something configuration on KPAC, and then it will start a build. And we actually represent a build also on our API. And there we will get some details about, like, for example, the commit and the image which got created out of that build. And once the build is complete and successful, we will do also a release. Also, if you do a change to the configuration or to anything else, we will always create new releases, basically. But also, if a release fails, you just did something wrong. Stuff happens, right? And you container image was built, and you have a new release, but that doesn't start, constantly failing. Your old release is still there. So your customers theoretically don't notice that, right? Deploio will only release stuff which basically is able to start. I mean, there's still stuff for improvement, I'd say, right? Yeah. Because we're currently just checking if your web server is available on the port with a TCP check. Very, very simple. That's very global, I'd say. But I guess for the future, it would be possible to define custom checks to make that better, to improve that. I think that's you now, right?
Yeah.
Yes. Good luck.
Yeah, this is going to be horrible to show.
That's actually, I can open it, right? We linked it.
Yeah, the issue is that the whole presentation is being shown. I can zoom.
Yeah, that's fine.
That works.
That's fine.
So, I mean, anyways, it's just to give you an overview of what we built here. So Nick already talked about these 3 clusters, right? And here on the left side, we have that control cluster. That's sort of I'd say, the control plane, as you would call it. So everything that is sort of the source of truth, I guess we can call it that. Here you define your applications, your builds. Well, the builds will be automatically defined, but yeah, you define your applications, and that triggers everything. So once you create an application, you can see it here, it will trigger a KPAC image. So yeah, essentially it goes over to the Deploio cluster, which you can see there. Here we trigger KPAC to do its job. KPAC will build your image and build your application and all that. And after the build, we basically go back. So we sync back again to the control cluster, and then things can take over again from there. Yeah, I don't need to show everything.
Anyway, it's quite complicated.
Yeah, but essentially, we switch constantly between these 2 clusters. but all the logic is handled on the control cluster, and these are just like supporting resources that we have, essentially. Yeah, I think we can get to the next one. So yeah, we encountered quite a bit of problems during the development of all this. So I guess we can start with the simple Rails app that didn't build. So when we started this out, we needed to figure out, well, can we do all of this from scratch? No, not really. We're a 4-people team. Yeah, I mean, Heroku probably has 100 engineers working on this stuff. So no, we can't. So we took a look around what is out there in terms of build packs. We found Paketo, which is, I think they're also sort of related to Cloud Foundry, but not anymore. I don't really understand. But in the end, they're open source. They're Apache 2 licensed, so you can use it for whatever you want. So we started using these build packs because they are pretty well maintained. They get constant automatic updates and all that. But our demo Rails app, or like even a Hello World Rails app, didn't build. So we had to do some fixes there. And we find ourselves constantly having to fix up stuff now, which was to be expected. But yeah, I think it's also interesting that you get to see something else, right? We never worked with build packs before, but now we can actually create our own build packs. We're also contributing back some stuff to Paketo. I mean, we'll see if they merge it ever. But there's discussions going on. It's always the way it is with open source. You try something and you live with it. But yeah, that was I think that's the biggest challenge of this whole topic, to get every application to build. And yeah, we're learning constantly. Second point, controller fights. So as you've seen before, we have quite a few systems interlinked together, and sometimes 2 systems will want to update the same thing, and then they'll run into an endless loop of trying to update the same thing. So yeah, we ran into this quite a bit, but I think now it's quite stable.
Until the next bug.
Until the next bug. We noticed some other stuff like DNS validation. Thanks, Joshua, for that one. So we noticed if you have an A or an U in your domain, our DNS validation completely didn't handle it. So it tried to, if you don't know, if you have a domain with an A, it's not actually like that in the actual resource record. So it's encoded in Punycode, which is sort of a, I don't know, standardized encoding. But yeah, we didn't really handle that. So we just passed it through and made those DNS requests with the wrong domain, essentially. That was fun. And other stuff like storage or not to provide storage, that's still an ongoing question. So we, from the beginning, we said we probably don't want to offer local storage. So if your application writes something to the local disk, for example, because that just makes everything way more complicated, because now you can't scale multiple replicas, or you need to be really careful with scaling to multiple replicas, because your application has to be aware of what each replica does. And yeah, we try to say, well, if you have shared data, put it on object storage, things like that. We'll have to see. I think this is something that we need to listen to customer feedback and see if they need it, if we need it. We'll see. The configuration system is pretty complicated. I think we've now documented it pretty well, but we'll have to see. This is also something we need feedback on. Are users even using it? Is the complexity necessary? Yeah, things like that. Another point was, what do we do if a release fails? I think Nick touched on that. If you push some new code and your new code crashes, let's say after 2 seconds in runtime, do you just let it crash indefinitely? Or do you at some point say, well, this application is probably never coming back, so we're marking it as failed. Yeah, and in the end, that's what we did. We now have a 5-minute timeout or something like that. After 5 minutes, we consider a release failed. But if you have a previous release that's still running, your application won't be down. It's still up. It's fine. You can fix it yourself, basically. But yeah, of course, if you've never had a running release before, it's sometimes a bit difficult to figure out what's going on. You just see that your release is failed. I think we can improve there. Yeah, of course, there's multiple teams involved in this whole thing. At 9, we haven't had that much experience coordinating. Like we have in this project, we have way more UI elements. We've never had such complex UI elements. So yeah, there's way more talk between teams and syncing, and also auxiliary services. So for example, databases, which is what managed services are offering, so that they're neatly integrated into the whole thing. Yeah. And yeah, last but not least, the language versions. Yeah, that's a hard topic. For example, one customer might want the latest and greatest version of Node.js, and another one is maintaining some legacy application, which is using maybe a 2-3-year-old version. And you need to find the balance somewhere. We can't support every version out there. Again, we're a small team. Yeah, we'll have to see how we can tackle this in the future, but I think there's lots of room for automation as well, so that these newer versions are automatically deployed when they're available, and that we somehow can maintain the old versions without completely breaking it.
But it makes us basically forking a lot of stuff.
Yeah,
that's the thing. Because Paketo decided differently, right? They just support, I think, the last 3 major versions.
Yeah, and now for Ruby, for example, they have the last 3, not even major, like the major. Yeah,
major and some. I'm not really. Yeah, I don't know, but yeah, in the end, you need to fork a lot of stuff and then handle it your own, and that's where actually the problem starts. Right? If you're just a 4-man team, then yeah, you need to decide. Yeah, it's always like in IT, right?
Compromises.
Yeah.
Yeah, I think this is for you.
Oh, yes. Yeah, what will come next? In general, currently, it's just about improving user experience, as Joshua can tell, I'd say, and the compatibility of build packs. I mean, just today, we had like a case with a Next.js application, and I actually had to look into the build pack system and how it's done, and I don't know. There's so many steps where you can like execute npm and npm scripts and setting environment variables, and the problem is that we are, I'd say, solely Go engineers. I think Go is our main domain. Golang is fine. For other stuff, we actually need to reach out to people, also working at 9. But yeah, that's always a bit hard. And another issue which we had is Git URLs, or which we still have. Like if you, for example, give an HTTPS GitHub URL, and you also define an SSH key, that won't work. It would be nice if it would tell you that it doesn't work, because what it currently does, it just passes it to the backend. KPack starts a build, and KPack notices I can't reach the repo because authentication. So what we did, we developed a small service, Git information service. The internal name is Inspector Gadget. And what we will do in the UI and in NCTL, we will reach out to Inspector Gadget, passing all the information we have about the repo and the authentication stuff to it. And it will try to connect to the repo, and if it's successful, it will return the branches and the tags available in that repo. And that goes fast because we don't need to clone all the stuff. We basically just need Git metadata for that. And it will also help in the UI, because if you need to select a branch or a tag, it might also be that the typical problem, main versus master, you select the wrong one, right? And currently KPack starts, and in the end it says revision not found, which means you don't have the branch. So that will be improved with Inspector Gadget. Static website build pack is something also people wanted, like Deploio would be cool if you could just run a damn static website, right? Currently it can't. But that is, did you already fix that? No, right? What? It's not deployed yet, right?
No, it's not.
Okay,
deployed.
But he is working on that. And it will be soon available. The big picture, the big question mark, let's say, Docker file support. Like it's obviously like the last resort if your build pack doesn't recognize the application, the framework, and your build fails. Like people, and I can understand that they say, like, why don't you support Docker files? Because I already have one. And that's fine in general. But the problem here is with the whole build pack system and KPack, we got a bit of improved security there. Because for example, at KPack, they build with a different user than the runtime user is. So there's already some security involved. And with Docker files, you would need to kind of take care that your stuff doesn't run as root and so. And yeah, we are thinking about it. And I guess at some stage it will come. But we need to do some underlying stuff. And also like building it. KPack doesn't handle Docker files. So we need to come up with our own build system besides KPack, right? Again, 4 people in the team. Object storage vendor change. I don't want to say any names, but we are not currently very happy with the object storage vendor which we have. And we are going to change that to a different one where the staging environment is currently already faster than our other environment.
That's why it was so fast before.
Yeah.
Staging, I faked it.
Yeah. But that's already developed. There just politics, I guess, is going on. And secure connectivity to services. Cyrill mentioned already databases, for example, are handled by a different team managed services. How do we connect from a Kubernetes service securely to a database, to Redis, to something else? We are currently exploring this, aka service mesh. Basically will come, I guess so, right? And that's also very, very complex stuff, I can say. But yeah, I guess it will come and it will allow us to just have secure connections, also with authorization frameworks in between your deploy application and the databases. Yeah, that's I guess what we are working on, right? Is there anything else?
I'm gonna add in so that there's already obviously we already do TLS between the services, but obviously like limiting this down more.
Yeah, and the idea is that it's transparent to the user, so they could just open a raw, unencrypted TCP connection to the service, but in fact it will be completely encrypted and verified that it's connecting to the wrong to the correct service and stuff like that.
Like back in the old days, I don't know, many of you know, right? We did that. You can't say that, right? Whitelisting is not allowed to say anymore. You need to say permitting of IPs at a firewall, and yeah, that's not really cool with Kubernetes, because when we do upgrades of nodes, we completely replace those nodes, and the IPs of those nodes will be changed. So relying on IPs in the Kubernetes world, or I could say cloud native world, right, is really hard. So that's why we need to come up with like the service mesh thing and all of that stuff. Yeah.
In a 4-man team.
Yes, we are 4. We also have a PO, Tim over there, which is pushing us very hard. No, he doesn't. Just joking. Yeah, questions. We talked a lot. Are there any questions? Yes.
Like, didn't you use a lightweight cloud foundry solution that runs in Kubernetes?
Oh, is there one? Okay. Actually, we didn't check. We wanted to have all the stuff on our side, right? Running Switzerland, Swiss hosting, and all that stuff, right? And we already had NKE, and we like to have control over all of that. I don't know. Maybe you could elaborate a bit more on that solution. What is out there?
We once run the full cloud foundry stack in Kubernetes. Mm-hmm. It was very complicated, and I do not recommend to do it.
Okay.
So we got rid of it. But I know there are some lightweight solution which doesn't have all the cloud foundry components, and I never used Heroku, but I think it's quite similar to cloud foundry.
I think the Cloud Foundry started, I'm not sure what it was called, but I think they eventually pivoted also to build packs. And now Heroku is also using build packs. So it's sort of so at least we were pretty sure to use build packs, as it's been sort of established as a standard. But yeah, KPack is already taking care of most of the heavy lifting. Of course, it's not like we still had to develop stuff around it, but I think it's pretty okay solution.
Yeah. Like also we had already NKE stuff, right? We also, for example, do automatic upgrades during the night. Yeah. Our whole system for upgrading software is quite interesting, basically, right? But everything is fully automated, and we wanted to stay with that. It's also for Deploio applications. I mean, from time to time, we need to upgrade build packs. We need to upgrade the underlying Ubuntu version. For example, what we don't want is you do like a git push. There is a merge request. He merges, and all the apps instantly will be upgraded. Because something goes wrong, like you have a mess. But that's why our configuration system and updating system basically goes step by step in the night in a configured maintenance window. And once there is an issue, it will actually stop. So we don't roll out shit, sorry, to all the customer apps. And we wanted to stay with that. We have some stuff developed, actually, some own stuff, right? Custom stuff. The guy in the front already knows that. He also introduced Bazel, so we are using one repo. We just have one Git repo, which is built with Bazel, which is also interesting. But yeah, it's quite sophisticated. It's great. Yeah. Other questions? Yes,
yes, you said that security concerns regarding the Docker file support. Are the security concerns related to build time, like you said, with the user, or to runtime?
Both. I'd say. I mean, if you look at OpenShift, right? If you look at OpenShift, how they are doing it, whenever you start something in OpenShift, it will get a random user ID. You will have just some random user ID, and that is cool. But then it's also not so cool because like open stuff like Docker files or Docker images. I don't know what I should take now. I don't know. It's just like I just take Redis now, right? For example, they just run under a completely different UID now, but they want to access stuff on the file system, which is not owned by that UID. So you really need to take care. It's always like simple deployment versus security. And for those Docker files, we would need to make sure, hey, you are just allowed to run as that user ID, because also the files which you might create at some potential local storage at some time, right? They need to belong to that user.
I could imagine to strike a balance so that security concerns are valid during build time, but that basically we don't care.
I think build time is, already fine, right? I mean, there's lots of rootless builders out there.
Yes.
So that's solved. We just need to integrate it, I guess.
Yes, yeah. That's also something. I mean, KPEG is there, like creating a whole build system, which is also based on reconciles. I think we wouldn't decide for anything else because it just fits into our ecosystem. It's hard. It's hard, and you already know it, right? There is stuff going on. Like a lot of like user experience improvements, and I think that should go first to make the flow more easy. Actually, I think I gotta restart it. It could be a heavy stone.
Doesn't show up anymore. Yeah. Any other questions?
Oh no. Yeah, Ramon.
Can I mix Deploio apps and like self-deployed Kubernetes? Like, can I have my own Kubernetes cluster and deploy Deploio apps onto that cluster?
Not yet, no.
Not yet.
I mean, yeah, I guess might be possible in the future.
Yeah, I think a way simpler thing, what we could do, and which would technically be easier, is if you having your own build nodes, if you're concerned, right, that others, people's applications are insecure and everything will get hacked. You could have your own build nodes. I think that is technically very easy for us to implement. But then you would also pay for those build nodes. I guess it's worth only if you have multiple applications.
Yeah, I'm thinking more about runtime. Like builds could even happen wherever, right?
We already separated that. So we could also say runtime is just your build node. Local. Yeah, that would be possible. Yeah.
I'm thinking about different deployment strategies. So I think at the moment when an app is built, you just replace it, right?
But it's basically like a Kubernetes deployment, right? The new app is started, and once it's reported as healthy, the other one gets dropped.
Okay.
Yeah, we currently have a rolling strategy.
Do you think of implementing other strategies in the future?
Yeah, I think it's come up already. Yeah. I think one thing that some applications might need is replace. So shut the old application down first, then deploy the new one. Of course, there will be downtime, but some applications just can't handle like two of them running at the same time, right? So I think that will come, or what you said, like switching over traffic, maybe sometime, but it sounds quite advanced. But yeah.
I mean, as we're using Kubernetes, right, we could basically leverage whatever is there for Kubernetes.
Yeah.
So I think it's fine. It's also a matter of customer requests. Always, right? We try to implement that stuff first, which is commonly asked for. Yeah. Oh, Tim. Hello, Tim. How big is our backlog?
Are you gonna ask Joshua because he's influencing that? No, we've got plenty of stuff to do, and I think the major priority right now is actually to make the user experience good with the services we've got in place. And after that, there are new features and there are new automations. But first of all, what's there should work seamlessly and smooth for the customer. And the backlog gets prioritized by what's important to the customers. You have one of the sooner you onboard, the more you can success.
There's also, like, for example, the other issue if you have your application but your entry point gets wrongly detected, right? We had that recently with a Python app, which was not using Django, for example, as a framework. It was just Python, and then like the detected entry point was just Python. So it started Python, exited immediately, right? I think it has no.
And there's nothing in the logs.
There's nothing in the logs. So how, like, obviously the customer said, "What should I do?" And I said, "What should the customer do?" Because it's hard to detect. Such stuff is hard to detect, and that's what needs to be fixed first. Yeah, it is.
Maybe as a quick addition, we've been talking about external services outside of Deploio. Those are not purely or solely engineered within the team which is working on Deploio itself. So the ecosystem will grow nevertheless once Deploio core features will be. So those developments are not completely independent, but kind of decoupled. So the ecosystem will grow, and the features should become more stable, more user-friendly.
Maybe something to add. They are 4 people, but it's only the back-end team. So we have another team that does the front end. So there are more people involved.
Yeah, we don't do it. We're just the backend. Yeah, we're just the backend guys.
Just the platform guys.
Just the platform guys.
Cool. Okay, so I suggest to go to the next.
Front end is
there.
One of them.
No.
The one without the Deploio hoodie.
Here in free.
So the other one.